Hello students, welcome back to Mathology classes 9396 where math meets logic. I am sure your summer vacations would have started and you would be enjoying it also. Along with the enjoyment, spare 2 to 3 hours for studies also. This will keep you in touch of the studies. So students, in today's class we are going to start chapter 2 of the NCERT book, that is Polynomials. First of all, we will be covering all the concepts and exercises from the NCERT book. After that, we will be taking some important questions from the NCERT exemplar. After finishing the exemplar, we will be taking some horse questions which are important from the point of view of the JEE mains exam. Students, if you like the way of my teaching, please don't forget to hit the subscribe button. So let's start chapter 2, Polynomials of the NCERT book. So students, in class 9, we already have studied about the polynomial in one variable and their degrees. If p of x is a polynomial in x, then the highest power of x occurring in that polynomial is called the degree of the polynomial. On the basis of the degree of the polynomial, we classify the polynomials in various categories. For example, a polynomial of degree 1 is called, what we call it? We call it linear polynomial. We call it linear polynomial. In basic form, it is y is equal to ax plus b. And why we call it a linear polynomial? Because when we draw the graph of this equation, when we draw the graph of equations of the type y is equal to ax plus b, we get a straight line. That's why it is called a linear polynomial. Linear means straight. Now, a polynomial of degree 2, we call it quadratic polynomial. We call it quadratic polynomial. And its basic form is y is equal to ax square plus bx plus c, where a, b and c are real constants and x is a variable. And what is the shape of a quadratic polynomial? We all know the shape of a quadratic polynomial is a parabola, right? It can be opening upwards or downwards. So, shape of a quadratic polynomial is a parabola. Similarly, a polynomial of degree 3, we call it cubic polynomial. And its basic form can be y is equal to ax cube plus bx square plus cx plus d. So these are some special names of the polynomials depending on their degrees. And a general name for a polynomial of any degree is called, we call it polynomial, which is the name of the chapter. And this name has been formed by joining two words, that is poly and nomial. Poly means many and nomial means terms. So this is the general name of an expression which contains many terms. So a polynomial of degree 1, we call it a linear polynomial. And why we call it a linear polynomial? Because it represents a straight line. A polynomial of degree 2 is called a quadratic polynomial, and its basic form is y is equal to ax square plus bx plus c, and its shape is a parabola. Degree 3 is a cubic polynomial, and general name for any degree expression is polynomial. Now, if p of x is any polynomial, if p of x is any polynomial and if we replace x by k, then we get the value of this polynomial at x is equal to k, and it is represented by p of k. So to find out the value of any polynomial at any given value of the variable, we replace that variable by that given value. And there is a special case. If p of k is equal to 0, then k is called 0 of the polynomial. If p of k becomes 0, then k is called the 0 of the polynomial. A little bit later on, we will study what is the geometrical significance of the zeros of any given polynomial. Now, before that, a natural question can arise in our mind that why should we study about the polynomials? Like, what is the reason due to which the NCERT has included this chapter in our book? It is very important to study the polynomials because many phenomena in the nature occurs in the form of the polynomial. For example, a simple population growth can occur in the form of a linear polynomial whose equation can be P0 plus IT, where PT is the current population, P0 is the initial population, I is the rate of growth, and T is the time period or time at which we want to find out the population. So, if we can find out the equation of this population growth for any population, we can project its future population and we can plan according to that. Now, if we throw a ball, its trajectory will go like this. And we know this is, if we extend it, so it will be like a parabola, and we saw that the shape of a second degree equation or quadratic equation, that is y is equal to ax square plus bx plus c, is a parabola. So if I can find out the equation of that trajectory, I can find out its highest point. We can find out its range, like how much distance it will cover. So this is the range of this parabolic trajectory. Similarly, we would have seen our dish antennas at the top, which is in the shape of the parabola. And what is the benefit of this shape is, if we find out the focus of this parabola, so focus is a point inside that trajectory, and if we can find out the focus of that antenna, so we would have seen that there is a receiver at this place. And why is it so? Because when the signal comes from the satellites which are there in the sky, so this parabola reflects all the signal to that receiver. So the strength of the signal increases and we get a better picture and sound in our TV. So these are the benefits of studying about the polynomials. Now let us try to understand what is the geometrical significance of zeros of the polynomial. So to understand that, let us first take a linear polynomial. For example, y is equal to 2x plus 5. Now to find out the zeros of this polynomial, first of all, we know that 0 of any polynomial is the value of the variable at which the expression turns into 0, or the value of the y becomes 0. So to find out the 0 of the polynomial, let us equate 2x plus 5 to 0. Now to find out the value of x, we will shift everything on the right hand side. So it will be 2x is equal to plus 5 will go on the right side. It will change its side. So it will become negative. Now 2 into x is equal to negative 5. So when we will transfer 2 to the right hand side, so it will go in the division, which is the opposite of the multiplication. So it will be x is equal to negative 5 by 2. So x is equal to minus 5 by 2 is the 0 of this polynomial. Now to see what is the geometrical significance of this value minus 5 by 2, let us try to draw the graph of y is equal to 2x plus 5. So if I put the equation y is equal to 2x plus 5 here, so this is the graph of y is equal to 2x plus 5, and if we check at what point it is crossing x-axis, so we can see it is crossing x-axis at negative 2.5, 0. So we saw that the graph of y is equal to 2x plus 5 is crossing x-axis at the 0 of that linear polynomial, and we know that its graph is a straight line, and a straight line can cross another straight line at only one given point. So we know that a linear polynomial can have at most one 0, and that point will be the point at which the linear polynomial is crossing x-axis. Now let us take a quadratic polynomial and try to find out its zeros. So for example, let y is equal to x square minus 5x plus 6. Now we can find out its 0 by equating the right hand side to 0. So equate x square minus 5x plus 6 is equal to 0. Now we can find out its factor by splitting the middle term. And how we split the middle term? Its middle term is negative 5, and product of the constant coefficient of x square and the constant term is 6. So we have to find out two numbers whose sum is negative 5 and whose product is 6. Whose product is 6 and sum is negative 5. So we can see it will be negative 2 and negative 3 because its sum is negative 5 and its product is 6. So we can break negative 5 into negative 2 and negative 3. So we can write x square minus 2x minus 3x plus x. So we replaced negative 5x by negative 2x and negative 3x. Now we can take common in between them. So what is common in these two terms? X is common. So remaining will be x minus 2, and in these two terms negative 3 is common. So remaining will be x minus 2 is equal to 0 is equal to 0. Now in these two terms we have x minus 2 as a common. So we can take x minus 2 common. So remaining will be x and negative 3 is equal to 0. So students, x minus 2 and x minus 3 depending on the value of x are two real numbers and their product is 0. Now we know the product of two real numbers can be 0 only if at least one of them is 0. So we can say either x minus 2 is equal to 0 or x minus 3 is equal to 0. So I can say x is equal to 2 or x is equal to 3. So x is equal to 2 and x is equal to 3 are two zeros of this quadratic polynomial. Now, to understand the geometrical significance of the zeros, let us try to draw its graph. So if I draw, let me write the equation. So this was the equation. Y is equal to x square minus 5x plus 6, and its graph has been drawn in green curve. So these are the zeros. So we can see the two zeros where it is crossing x-axis is at 2 and 3. And we saw that 2 and 3 was the zeros of this polynomial. So we can see a quadratic equation crosses x-axis at its zeros. In fact, any quadratic polynomial of the form y is equal to ax square plus bx plus c has the form of a parabola. Now, the parabola can open upwards or downwards. It depends on the sign of the coefficient of x square, that is a. If a is greater than 0, the parabola open upwards. And if a is less than 0, it open downwards. Now, three cases arises. The parabola can intersect x-axis at 2 points. When it is opening upwards, then it can be like this, and if it is opening downwards, then it can be like this. So in this case, the parabola is having two zeros at A and A dash. Similarly, the parabola can touch x-axis at only one given point. Like if it is opening upwards, let me draw it again. If it is opening upwards, then it can go like this, and if it is opening downwards, then it can go like this. So in this case, parabola is having two equal zeros or one zero. So here there are two distinct zeros, and here they are having two equal zeros or one zero. Now in the third case, it can happen like the parabola is not touching x-axis at all. And we know zeros are the points where the curve is crossing x-axis. But in this case, the parabola is not touching x-axis. So in this case, there are no zeros. So there is not a single value of x where the value of y becomes 0 or this expression is equal to 0. Now let us take an example of a cubic equation. So what do you think? How many zeros will it have? To understand that, let us take an example. Y is equal to x cube minus 16x. X cube minus 16x. So to find out the zero of this polynomial, what we will do? We will equate the value of y to 0. It means to find out its zeros, we can write x cube minus 16x is equal to 0. Now, x is common in both the terms, so I can take x common. So it will be x square minus 16 is equal to 0. Now we know that 16 is the square of 4. So I can write it x square minus 4 square. Now we can apply the formula a square minus b square in this equation. So I can write x minus 2, x minus 4 and x plus 4 is equal to 0. So there are three terms whose product is 0. So this will be possible only if at least one of them is 0. That is x is equal to 0 or x is equal to 4 or x is equal to negative 4. So this is a cubic equation, and we saw that there are three real zeros or distinct zeros for this cubic polynomial. Now let us try to draw its graph and find out what is the geometrical significance of the zeros of this polynomial. Will this cubic polynomial also crosses x-axis at these points or not? So let us open the Desmos and let me write the equation. Y is equal to x cube minus 16x. So this is the purple curve, and we can see this curve is crossing x-axis at these given points. And we saw that it's the zeros of this polynomial was -4, 0, and 4, and we saw that the curve is also crossing x-axis at these points. So this result is in relevance or is in accordance with the previous results which we got, that the zeros of any polynomial is the points where the curve of that polynomial crosses x-axis. So we can see here we got the zeros also, 0, 4 and -4, and as we saw in the curve, it is also crossing x-axis at those given points. Let us try to draw some other cubic curves also to check at how many points a cubic equation can cross x-axis. So y is equal to x cube if we take, so it is crossing x-axis. Let me remove the other graphs. So y is equal to x cube is crossing x-axis at only 0, 0. And let me write another equation, y is equal to x cube minus x square. So y is equal to x cube minus x square is crossing x-axis at 0 and 1. So it is crossing x-axis at 0 and 1. So we took three cubic equations, x cube minus 16s. So we saw it was crossing x-axis at 3 points, -4, 0, 0, 0, and 4, 0. Y is equal to x cube. It was crossing x-axis at only 1 point, 0, 0. Y is equal to x cube minus x square, crossing x-axis at 2 points, 0, 0, and 1, 0. So in this way, we can say that a cubic equation will cross x-axis maximum at 3 points. It can cross axis at 1 point or no points, but maximum it can cross x-axis at only 3 points. So we can generalize that a polynomial can cross axis or will have zeros, maximum zeros equal to the degree of that polynomial. Now students, we have seen that the number of zeros of a given polynomial is equal to the number of times its graph is crossing x-axis. So now let us come to the exercise 2.1 where we can apply these concepts. So let us see exercise 2.1, question number 1. The graphs of y is equal to p of x. P of x is just a notation and it means that p stands for polynomial. So y is a polynomial in x. So how we read it? Y is a polynomial in x are given in the figure 2.10. So these are the figures below for some polynomials p of x. Find the number of zeros of p of x in each case. So we know the number of zeros of a given polynomial is the number of times the curve is crossing x-axis. So in the first part, we can see that the straight line is just parallel to x-axis and it is not possible for this line to cross x-axis because this distance, let me choose a different color, let me choose a green color. So this distance is fixed. So this line is parallel to x-axis, so it will never cross x-axis. So what we have to find? Number of zeros. So in this case, number of zeros will be 0. Now in the second case, we can see here, this curve is crossing x-axis at only one given point, and after that, that curve is going up and up and up. So we can see here, as it is crossing x-axis at only 1 point, so it will have 1, 0. Now in the third case, if we see the curve is crossing x-axis at 3 points, let me choose different color. It is crossing x-axis at 3 points. So it will have 3 zeros. Some students might get confused that this curve is crossing y axis also at this point. So they might think that this is also 1 0 of this polynomial. But remember, students, we learned that the number of zeros of a given polynomial is only number of times that curve is crossing x-axis, not y-axis. So this is not 0 of this polynomial. So its answer will be 3 only. So there are 3 zeros for this polynomial. Similarly, in the fourth example, we can see here that this is a parabola opening upwards and it is crossing x-axis at 2 points, so it will have 2 zeros. In the fifth example, the curve is crossing x-axis at 4 points. Again, we have to be cautious, it is crossing y-axis also, but the point where the curve is crossing y-axis is not a 0 of a polynomial. So in this case, number of zeros will be 4. And here, the curve is crossing x-axis at only 1 point and it is touching x-axis at 2 more points. So there are 3 points where the curve is either crossing or touching x-axis. So this curve will have 3 zeros of this polynomial. So this was exercise 2.1 of NCERT. I hope this would be clear. This was a very easy exercise and we had to just see at how many points the curve is crossing x-axis, and that will be equal to the number of zeros of that polynomial. This is the homework for you, students. Please stop the video and try to solve them. These questions are just based on the concepts which you just learned. This was all for today's lecture. In the next session, we will meet with the further concepts and exercises of the NCERT Class 10th Chapter 2 Polynomials. Till then, take care, study for at least 2-3 hours daily, and don't forget to enjoy your holidays. If you liked the video, please hit the subscribe button.